Alrighty, here we go with number 10. They're giving us the derivative function, and they want us to answer questions about the behavior of the function f at x equals -1 based on the derivative. So we're going to go to our graph screen, and first I need to plug in my y1, which is going to be x squared plus 1 all raised to the x, and then subtract out a 1. And I don't want to see, well, that is the derivative function. So I do want to see the graph of the derivative function. I don't need to see the graphs of the next two derivatives. And I'm going to go delete what I had in here for other equations that I used on my last problem because I don't need them. So all I'm going to be looking at now is the graph of my derivative. And I'm using whatever window I had previously, which does include x equals -1. So at x equals -1, my derivative is negative, which means my function is decreasing, which means this choice is not correct. When I look at my derivative function, the derivative is increasing at -1, which means that the function is concave up. And since the derivative is defined here, the function must be continuous at this point. So the answer is going to be 2 and 3 only. And I'm just realizing that I never showed you the window to confirm, in fact, that we were looking at x equals -1 on that window. I think it's worth just showing real quick. I can go to trace and then type in a -1, and you can see that point. So you can see that the derivative is negative and increasing there. All right, next problem. They're giving us the derivative and they want to know what's happening at x equals 2. So I'm going to go ahead and graph this as well. Delete the one I had in there before, and I'm going to plug in x minus 2 and square that term. And then my next term is x minus 3. And I'm going to, let's see, they're asking about at x equals 2, which I know is within my window. So I'm going to go ahead and hit graph, and I'm just looking at this function I typed in. I'm not looking at its derivative or second derivative. And I think that there's a 0.20 here, but I'm going to go ahead and do trace and plug in a 2 and confirm that there is the 0.20. So first of all, this is the derivative. If the slope of the function at x equals 2 is y equals 0, then I do have a horizontal tangent line. When I look at this derivative function, I see the derivative has a local max, but the function will not, because the function has a local max when the derivative changes from positive to negative. That does not happen here. And then last, the function will have a point of inflection where the derivative has a local max or local min, any turning point, which does occur here. So there will be a point of inflection on the function, and my answer is 1 and 3 only.